Okay, now that we've done our little algebra review, we've discussed angles in degrees, angles in radians, how to convert angles, how to use coterminal angles. We can now introduce what is trigonometry. So we're going to begin by doing the definition of the 6 trigonometric functions. And how do we define them? There are 6 of them. I'm going to explain why there are 6 of them. And so again, this is going to be the basis of the entire course, trigonometry. What is the functions? So what we're going to do is we're going to pick an angle, and we're just going to pick it in quadrant 1 because it makes it a little bit easier to explain, but it could really be in any quadrant. So here's my angle, somewhere in quadrant 1. It looks a little bit like 45 degrees, but it wouldn't have to be. And so again, I'm going to call my angle, I'm going counterclockwise, it's going to be theta. And so what I do here is I create a right angle by going from the terminal ray to the initial ray. And so this would create a perpendicular, so this would be 90 degrees. And then I could do this infinite amount of times. Like I could make it a little bit bigger, and it would still create, so I could keep going down, right? Because remember, the angle, the ray, it extends indefinitely. So you could keep making right angles perpendicular to the initial ray. But the further along you go on the line, the bigger the triangle is going to become. So I'm going to label the sides of the right triangle. So this is I'm going to call this A, I'm going to call this B, and I'm going to call this C. And then I'm going to call this one A, this is B, and this is C. So I'm going to take these on the side here to make it a little bit easier to look at. So I got my purple triangle, which is A, B, C. And then I got my blue triangle, which is a little bit bigger. And, oh, I'm sorry, I didn't want to call it ABC. I'm going to call it A prime, B prime, C prime. I can't call it ABC because I already used that for the purple one. I got to call it something different. So A prime, B prime, C prime. And they're all bigger, so I really can't call them the same. I can physically see that they're bigger. So when you do a ratio of the sides of the triangle, a ratio is when you take 2 numerical values and you compare them to each other. So for example, if you have a sibling, like a sister, you could do the ratio of her age over your age, or you could do the ratio of your age over her age, okay? So just as a quick thing, like say you're 20 and your sister's 25. This is you, this is your sister. You could either compare your age over your sister's, or you could compare your sister's age over yours. Okay, so there would be 2 different ratios that you could do. So we have 3 sides of the triangle. So the ratios I could create would be, I could put, and as a quick review of a right triangle, the ones that are, the A and the B are called the legs of the right triangle, and C is called the hypotenuse of the right triangle. And the hypotenuse is the leg that is across from the right angle, but it has a special name. We call it the hypotenuse. The other ones are just called legs. So the small triangle, you could put leg A over the other leg B, or you could do the opposite, B over A. Or you could take leg A and put it over the hypotenuse, or you could do it the other way. Or you could put leg B over the hypotenuse, or do it the other way. And if you try to do any more, you won't find any more possible ratios. There are 3 sides and 6 ratios. Hence the word 6 here. You can kind of see what's going to happen. So if you look at the large triangle, again, the same ratios can happen. Oops, B. But it's going to be with the other types of A prime, B prime, C prime. So this is the basis of what's happening here. So the key of these triangles happen right here. The key of the triangle happens that this is the angle theta. That no matter how big I was making the triangle, the common thing of the triangle was the angle theta. And so what happens is that no matter how large the triangle gets, the ratios will always be the same. They will always reduce. So A over B will equal to A prime over B prime, and so on. And this will be true for all the ratios. So the key that's happening here is that no matter how large the triangle becomes if the angle is the same, and that is really the key. The star of the show is the angle. If the angle is the same, the ratios are the same. So your legs and your hypotenuse can get huge, but when you put them over each other, they will reduce to be the same. So for example, 1/2 and 4/8. So 1 and 2 are smaller than 4 and 8, but 1/2 is the same ratio as 4/8. So again, the key is really the angle. So what we do is we actually create a name for each of these ratios in the triangle. So I'm going to draw the triangle one more time right up here. Let's draw a nice little triangle. Perfect. And so I'm going to put my angle here. And so we're still going to call this A, B, and C. And so now we're going to have 6 trig functions. So the first one is going to be called the sine of theta. Thankfully, we don't have to write all those words. We have a short version. It's like we don't write the square root. We have a symbol for the square root. And here we don't have a symbol. We just use an abbreviation of sine. So sine theta. And this is going to equal to B over C. Then we have the cosine of theta. We use, again, the first 3 letters, cosine. And this is going to be A over C. I'm going to write it here so I have a little bit more room. Okay, then I have the tangent of theta. Again, we use the first 3 letters, T-A-N. That's going to be B over A. Then I have the cosecant of theta. Now here I run into a little bit of an issue. I cannot use the first 3 letters because if I use the first 3 letters, it will look like cosine. So what we do is we use C as C of theta. This is going to be C over B. Then I have the secant of theta. Here we can use the first 3 letters. This is going to be C over A. And I have one more ratio, which we call the cotangent of theta. And again, we can use the first 3 letters. Yay. And that's going to be A over B. So here it is. Here is what you're going to be studying for the next few months. Here are your 6 trigonometric functions. 6 ratios. Now, one of the things, the most common thing I see, especially at the beginning, is that people write the trig function without the angle. It makes absolutely no sense. Everything is dependent on the triangle you're creating with the angle you have. So you want to think about it like if you write a trig function without an angle, like if you write sine is B over C, it's like you writing a square root symbol with like nothing underneath. It just doesn't make any sense. You have to have an angle. Like, just really try to remember that the angle is the star of the show. So there is a little acronym to help you. Remember, it's called SOHCAHTOA. So the key here is, I'm going to underline it in different colors. So we can use orange, the SOHCAHTOA. So in the first one, so if we look at the triangle again, let me draw it one more time. We're going to be drawing a lot of triangles in this class. Oh, it's not perfect. Here we go. So here's our angle. So if we have what is across from the angle, we actually call this the opposite side. So I had it as B, and we call this the opposite side. So you can use the letter O. Then next to it was the letter A, and we actually call this adjacent. Adjacent for next to, so capital A. And then the hypotenuse, we'll use the letter H for hypotenuse, which was C. So O, A, and H is where you get the SOHCAHTOA. So you get that the sine of theta, if we go back to our definitions, I assigned sine theta B over C. Well, I didn't assign it, the person who created trigonometry. So it's B over C. So if you look, B was opposite, over C, which is hypotenuse. So O over H. So that's the orange part, the SOHCAHTOA. So SOH. Then you have the cosine of theta. So if you look at cosine, it's assigned A over C. So A is the adjacent and C is the hypotenuse. So that's the CAH part, the green part. And then we have tangent. And the tangent of theta is assigned B over A, which was O over H. So here you have SOH. And then the green part is CAH. And then the blue part is TOA, SOHCAHTOA. So that can help you remember opposite, adjacent. Now, what's important to notice is that the opposite and the adjacent can switch, because if you wanted to, which I did specifically on purpose in number 1, so if you look at number 1, I put the angle up in the above corner. So the hypotenuse will never change. The hypotenuse is always the one across from the right angle. But the opposite and the adjacent are the legs. So depending on where your angle is, it could change the opposite and the adjacent. So we're going to do one example. So in this situation here, this would be considered the opposite. And this is going to be considered the hypotenuse. If the angle was here, hypothetically, the A would be the adjacent. Okay, so it is important where the angle is placed. Now I am missing the third side. But luckily for us, in a right triangle, we have a relationship between the 3 sides. And that relationship is called the Pythagorean theorem. A squared plus B squared is equal to C squared. So we have that A squared plus 5 squared is equal to 6 squared. A squared plus 25 is equal to 36. A squared is equal to 11, which means that A is equal to the square root of 11. I can't reduce that, so it has to stay as the square root of 11. And then you start to write your 6 trig functions. So the sine of theta is the opposite over the adjacent, over the hypotenuse. So this is going to be 5 over 6. The cosine of theta is the adjacent, square root of 11, over the hypotenuse. The tangent of theta is the opposite over the adjacent. Now, we can't have a square root in the bottom, so we do something called rationalizing. You take the radical and you multiply it to the top and the bottom. Because remember, you can do something as long as you do it to the top and the bottom. So at the bottom here, the radicals cancel each other out. So at the bottom we get 11, and at the top we get 5 square root of 11. Okay, the cosecant of theta is going to be, so in the next material, I'm going to teach you a trick on, if you know sine, cosine, and tangent, how you're going to know secant, cosecant, secant, and cotangent. But for now, we're just going to look at the definitions. So if we go back up to our definition, cosecant was C over B, so the hypotenuse over the opposite. So the hypotenuse is 6, the opposite was 5. Secant is going to be C over A, so that's going to be 6 over the square root of 11. But again, I have to rationalize, so 6 square root of 11 over 11. And the cotangent, which was the last one, was A over B, adjacent over opposite. And the reason that, I'm just going to give a little preview, the reason that you can easily find cosecant, secant, and cotangent is because they are called the reciprocal of sine, cosine, and tangent. And the reciprocal means that you are switching the top and the bottom, because if we look at how we defined it, these were reciprocal. A over B and B over A are reciprocal of each other. So once you know the other one, you can just flip it. But that will come later.